The amplitude. None. Good. Oh, yeah, no. Okay, so the amplitude was none. What was the period of the function? Pi. Okay. So it worked a little faster. Okay, cycled through its values a little faster. Now remember, if you start at 0 and you make that fourth mark pi, okay, the tangent function looked like 0, up, asymptote, okay, down, 0. It looked like this. You have this from your investigation. Okay? Just changed it. Okay. All right, so this is what we have. But we talked about how this is not probably the most useful way to start with the tangent function because you don't get to see two asymptotes and what's between them. So I think Julia maybe made the idea here that it would be nice to start with all these points around 0 like this, okay? So that we could start with more than a period for the tangent function just because you really want to see at least between two asymptotes. So when you shift, you can shift both asymptotes and see your new space in between, okay? Now, if the period of the tangent is pi, that means this graph is being scaled by fourths. Okay, so this asymptote is happening at pi over 2. And at negative pi over 2 is the other asymptote, just so that I can understand that properly. Okay. All right, so we're going to do what we did before. Changes in period. We're just going to change the period so we can still write our tangent like this, but just kind of change this number and change the scale. Reflections are going to move things above the axis to below if they're vertical, if they're horizontal from the left to the right or the right to the left. Okay. Vertical stretches and compressions. There is no amplitude here, but you still have this point at 0. That's like your midline point, okay, kind of the middle of your function. You have a maximum 1 unit above that and a minimum 1 unit below that. So if I put like a 2 in front of the tangent function, the middle points are going to stay wherever they are, but this maximum is not going to be 1 point above it. It's going to be 2. Okay, 1 times 2 is 2, just like a stretch, and this one would go down to negative 2. So let's look at graphing it. Yep. Sorry, I have to move a lot of slides to get where I want, because these are all our things from yesterday. Maybe not that many slides. Okay. So we're going to graph 2 times the tangent of 3 theta. Okay. This is example 5 if you got the note-taking guide. So the first thing I'm going to do is I'm going to put my tangent graph on here as the parent function. So we just saw what the parent function looks like. If you don't know what the parent function looks like, refer back to what we just drew. Okay? So there's one period of the tangent function, but this period is surrounded by asymptotes. Okay? Now, 2 changes here, the 3 and the 2. What's the 3 going to affect in our graph? The period. What is the normal period for the tangent function? Pi. How is that 3 going to affect the period? Not 3 pi. Because remember, if it says 3, it's really a horizontal compression, which means we're multiplying times 1/3. So the period is actually going to be pi over 3. Okay? Now, that still means 1, 2, 3, 4. This is pi over 3. So what does each mark on this graph represent if that fourth mark is pi over 3? We've done this for our sine and cosine graphs too. We figured out the period. We put it on the fourth mark. What do we need to do that to figure out this? Matt? Good. We divide it by 4 and we get pi over 12. So every mark on this graph represents a pi over 12. So 1 pi over 12. The next one would be 2 pi over 12, which is pi over 6. The next one would be 3 pi over 12, which is pi over 4. Okay. And then on this side, we would just have the negative versions of those. My goal is just to get these two asymptotes where they need to be and do whatever twisting, turning, stretching has to happen in between with that function, and then I can just repeat that over and over again across my graph. Okay? So I've taken care of the 3 just by changing the period of the graph. How does the 2 affect the graph? Mincha? Good. We stretch it vertically. Now, it used to change the amplitude. Technically, the tangent function doesn't have amplitude, but we can still perform a vertical stretch. Those midline points, or the points that would kind of divide our function in half, are going to stay there, and we're going to stretch these other reference points that we have towards or away from them by whatever factor this stretch or compression says. So it says by a factor of 2. So currently, these points that I've circled are 1 unit above or 1 unit below this middle point. I'm going to take that 1 and multiply it by 2, and 1 times 2 is going to give me 2, which means my graph of this function I expect to be 2 units above where that middle point is and 2 units below where that middle point is, and the middle point still remains. So my new tangent function looks like this. Okay. And you can see that vertical stretch. See how it kind of appeared wider between the asymptotes before? Did I shift it all? So are my asymptotes going to move? No. So they're still here. Okay. And if you wanted to cycle this graph, you would now just start at the next asymptote, and you would do point at -2, point at 0, point at +2, draw the curve, and give yourself another asymptote, and just kind of copy-paste this across the graph in either direction. Monet? Well, we technically had a horizontal compression, so they did move. But we just moved them by renumbering the spot they were at instead of literally moving them. But they only move with horizontal stuff. So horizontal stretches are compressions, but for that we just change the number that they're sitting at. Otherwise, you're not going to move them over left or right unless you have a left or right shift, a horizontal shift. Okay? Yeah. All right, so here's one where, sorry, it says pi over 3 for those of you that can't see it. So this is just the basic tangent function. The only thing it has is a period change. So you know what, graphically, if I know what I'm doing, this makes my life really easy, because this setup for the tangent function is going to not move. Because if my only change is a period change, how am I going to adjust that on my graph? I will make sure that the asymptotes are sitting at a new number by adjusting the scale. Right. So I can be confident that I can go through and draw all this on my graph. I could just keep repeating this across already. Then I just got to put the right numbers on the scale to account for this. Okay. So again, the normal period of the tangent function is pi. The horizontal stretch or compression here is pi over 3. So I'm going to multiply pi by the reciprocal of that, 3 over pi. Giving me a period of 3. Don't be stressed out that the period is 3, but we put it at the 4th mark. No big deal. Okay? So the number 3 goes at the 4th mark. Meaning, what does each mark on my graph represent? 0.75 or 3/4. That amount divided by 4. Okay, so the first mark is 3/4. The next mark, remember, every time I move over a mark, I am moving over 3/4. So if this is 3/4, the next one's not 4/4, okay? The next one is 6/4, which reduces to 3 over 2. And then 6/4 plus 3 more fourths would be 9/4. Okay? And then 9/4 plus 3/4 would be 12/4, which makes very good sense because I have a 3 right there, so that makes me happy. And then I could copy those negative values on the other side of this graph. Is this okay with everybody? So really the only thing that's changing from the sine and cosine is you have to start with a little bit more complicated parent function, that there's no amplitude, but you still just stretch or compress these points away from that middle of the function. Everything else is going to work just as it did before. So really this is about knowing your parent functions and starting with the right graph to begin with. Monet? Uh-huh. Yeah, there was. So we talked about drawing it from 0 to here, so it looked like this. Okay. So this is one period of the tangent graph from here to here. But that's an annoying period to look at because I don't get to see two asymptotes and what's happening between. So rather than use that period, my choice is to use this period because once I can get those two asymptotes and what's going on in between, that's what I can copy to the left and to the right to complete my graph. So you don't need to use that other part. But I put it up there originally because that's what we would originally think of. And then we're saying, for tangent, because it's so weird, let's use this other part of it. Okay?